Hello, welcome sa ating next tutorial. So, design of two-story reinforced concrete residential structure using STAAD.Pro and STAAD Advanced Concrete Designer RCDC. So, during the course ng tutorial natin, so probably meron tayong five main objectives. Yung number one is calculate wind pressure for components and cladding per NSCP 2015 and ASC 710. So, i-design number 2 is i-design natin yung roof truss and purlins per NSCP by LRFD method. Then, yung number 3, i-derive natin yung mga dead load and live load values per NSCP, which is yun yung gagamitin nating loading values doon sa ating STAAD model. And yung number 4, di-discuss natin yung seismic parameters input sa STAAD per NSCP 2015 UBC 97. And lastly, yun, along modeling yung STAAD model natin, i-analyze natin yon, then i-design natin yung concrete elements, yung concrete frame elements sa STAAD Advanced Concrete Designer RCDC. So, yun yung beams, slabs, columns, and footings. So, ito yung project natin. Okay. So, typical 2 by 2 bay by 2 bay frame. So, 4 meters, 4 meters dito, then 5 meters, 5 meters doon. Then, may naka-overhang lang siya doon. May balcony doon, cantilever, which is around 2 meter with the curved beams. Then, yung truss natin is 2 meter height. Then, may overhang siya na 0.8. So, kung 4 meters to plus 0.8, so total 4.8 meters. Then, yung purlins spacing natin, 0.8 meters okay, on centers. And yung truss spacing natin is 2.5. So, yung mga trusses, yung purlins natin na yan, dito mas madali kasi i-discuss dito. Okay, so minodel ko siya sa Pro Structures, Bentley Pro Structures. Hindi to kasama sa tutorial, no? So, minodel ko lang para mas madali kong may discuss yung project natin. So, parang ganito yung framing, yung structural framing ng project natin. No? So, ito yung truss, 2 meter height, then 4 meters plus 0.8, so 4.8. So, yung angle ng truss natin, bale, so 2 divide 4.8, then i-inverse natin tangent, so around 22.62 degree. So, yan. Yung yung roof slope natin is 22.62 degree. Then, yung roof mean height natin para sa wind load calculation is 7 meters. So, 3 meters, 3 meters. And yung kalahati ng 2, 7. So, but hindi ko in-include yung 1.8 kasi nakabound yun sa soil. So, yung roof mean height calculation is galing lang dito. Okay? Sa level na to after 1.8. Okay? Yun lang yung mga tatamaan ng wind. Okay, so ito yung project natin. So story levels, putting to ground floor 1.8 meters, ground floor to second floor 3 meters, then second floor to roof beam, so 3 meters, then roof beam to apex, so 2 meters, so total 9.8. Ngayon, structure category natin, okay, from NSCP tables, okay, standard occupancy structure, so all structure housing occupancies or having functions not listed in category 1, 2, 3, and 5. Okay, so itong 1 and 2 essential, 1 is essential facilities, 2 is hazardous facilities, and 3 is special occupancy structure. So for offices and residential, so okay na itong occupancy, itong occupancy category 4. So, project location in Malolo City, Bulacan, seismic source type A. So, yung project is 40 kilometer okay, from the known seismic source. Okay, so sukatin nyo lang, no? I-plot nyo yung project location nyo, then sukatin nyo from the pole, then makukuha nyo na yung distance. So, since 40 kilometer yon, so hindi siya within 15 kilometer. So, ang mga magiging values natin dyan is 1.0 lang. So, pagdating natin sa seismic, ma-discuss natin ito mabuti. Okay. Then, so, yung wind speed natin, so sa Bulacan is around 250 kph. Ayun. And baka malito kayo dito, no? I-check nyo yung nasa ilalim. Category 3, 4, 5. Okay? May tatlong wind maps kasi doon sa NSCP. Okay? May iba-ibang wind velocity values yon. So, ito 1, 2, and 3. Okay? So, category 3, 4, 5. So, mas less yung wind velocity dyan, which is ito yung ginamit natin. So, 250 kph. Then, and ito yung para sa category 2, ito yung para sa category 1. Okay, loadings. Ito yung loadings natin. Okay, so hindi mo natin i-discuss yung concrete frame, no? Kasi ang i-design natin ngayon is yung purlins tsaka yung truss. Okay? So, ito yung mga loadings natin. Okay, so mamaya i-discuss natin to pag nag-loading na tayo sa truss. So, wind parameters natin, velocity of wind is 250 kph, importance factor is 1.0, then exposure B, typical residential structure in urban area. Okay, so para dun sa unang objective natin, calculate wind pressure for components and cladding per NSCP 2015. So, ang gagamitin natin dyan, meron kasing dalawang procedure or tatlong procedure ng calculation ng wind sa NSCP. Merong analytical procedure, merong simplified, meron pa yung wind tunnel. So, since simple lang yung structure natin, simplified method lang yung gagamitin natin. Okay? So, paano siya ma-qualify as simplified? Kailangan daw yung building natin is yung height is less than 18 meters. Yung building height natin is 7 meters lang. So, qualify yung building natin. And kung imagine mo yung 18 meter, it's around 6-story building. 2-story building lang yung i-design natin. So, ayan, sa simplified procedure tayo. Okay, ito yung formula para sa pag-calculate ng PNET. Okay? PNET, lambda, KZT, PNET 9. Okay? Actually, typo error siguro to. Dapat ito PNET 9. 30 is 30 feet siguro. No? PNET 9 is 9 meters. Okay, anyway. Ayun, PNET 9 yan. So, lambda is adjustment factor for building height. Okay? Nasa figure daw na to, which is, ito na yun. Okay? So, exposure B tayo. Then, yung roof mean height natin is 7. So, consider ko yung 7.5. So, 1.0 lang yung lambda factor natin. Then, yung KZT naman, merong rigorous calculation yan just to simplify the calculation. So, i-assume ko na lang yan na 1.0. Then, yung PNET 9, it's not PNET 30. Madali lang yan. Okay? Madali lang i-calculate yan. Using tables lang yan. Okay? So, dito, ito yung tables na yun. Yan. Okay? So, para sa components and cladding. Okay, take note, no? So, take note, kailangan yung kukunin nating forces is para sa components and cladding, hindi sa main wind force system. So, ayan, ito yung definition sa ASCE 710. So, CNC, which is components and cladding, elements of the building envelope that do not qualify as part of the main wind force processing system. Main wind force resisting system is an assemblage of structural elements assigned to provide support and stability to the overall structure, generally receive wind loading from more than one surface. So, merong magandang komentaryo si ASC is 710 dyan. Okay? So, yun. Cladding receives wind loads directly. Component receives wind loads directly or from cladding and transfer to the load to the main wind force resisting system. Examples of components include fasteners, purlins, which is yung didesign natin, purlins, girts, studs, roof decking, and roof trusses, which is yung i-design natin. So, kaya ang dapat natin na gamitin na forces na wind pressure doon sa purlins and roof trusses is galing sa components and cladding pressure calculation. Okay? So, yun. So maraming tables doon. Pagpunta mo ng NSCP, napakadaming tables doon para sa mga wind pressure. Okay? So, pero tandaan nyo lang itong, okay? Ito yung mga steps niyan eh. Actually, may steps na dyan kung paano yung pag-calculate ng wind pressure. Okay? So, ito yung mga steps niyan. Okay? Pero anyway, gagawin naman natin dito eh. So, makikita nyo rin yung instruction. Okay? So, ito yung dito magpo-fall yung structure natin. Ganito yung shape niya. Okay? So, gable roof. Then, may 5 pressure zones. Okay? Which is 1, 2, 3, 4, 5. So, i-eliminate natin yung 4, 5 kasi para sa walls yon. So, roof trusses kasi yung design natin. So, doon lang tayo mag-concentrate sa 1, 2, and 3 zones. Okay? Ngayon, ipa-plot lang natin yan, ano? Wind speed natin is 250 kph. Okay? Then, yung angle ng roof natin is 22 degree, which mag-fall from 7 to 27. Ngayon, magkakaroon lang tayo ng dalawang values dito ng wind, okay, per zone dahil sa effective wind area. Okay? Magkaiba yung effective wind area ng purlins kaysa doon sa effective wind area ng uh, ng ng truss. Okay? So, yung purlins natin so 0.8 ano, then tsaka 2.5. So, kukunin mo yung i-tab view natin ito. Ayan. So, i-tab view natin yan. Tanggalin siguro natin yung shadow. Okay, so ito yung purlins natin, no? So yung tributary niyan is of course yung spacing din 0.8 then times mo sa 2.5. So 2.5 times 0.8. Okay? So pero may magandang discussion diyan si NSCP. Okay? Ang sabi niya dito ito ASC 7 ito. Ito yung NSCP. So yung effective area width need not be less than 1/3 of the span length. Okay? So, dun sa purlins natin, okay, 2.5 yung between supports, which is ito yung span. So, divide mo to sa 3, which is 0.833. Pero yung design natin na spacing is 0.8. So, dapat hindi ka na bumaba dito. So, ito ang i-consider natin, yung 0.833. So, ngayon, i-multiply natin to sa 2.5. So, 2.08. So, kaya pagpunta natin dito sa table na to, okay, so magpo-fall siya sa 2.0 area, okay? So, area ng effective wind area, 2.0. So, tatlong zones yan, okay? 1, 2, 3. Then, may different effective. So, 2 kaya yon. So, 2.0, 2.0. So, ngayon, tinabulate ko na dito yan. So, pare-pareho lang sa positive yung direct pressure load, no? Then nag-iba lang siya doon sa suction, doon sa suction pressure. Okay? Magkakaiba yung values niya along zone 1, 2, 3. Then, ayun. So, from dito, tinabulate ko lang dito. Okay? Then, para naman doon sa truss natin, so magpo-fall siya under sa 9.5 square meter effective area. So, paano natin i-calculate yung effective area ng truss natin? Okay. Ayan. So, ito yung truss natin. Okay. So, yung effective width niyan is, of course, yung spacing din, which is 2.5. Then, yung total span niya is 9.6. Okay? So, from dito sa dulo ng truss. Okay, 9.6 times 2.5. So, 24 square meter. Okay, 24 square meter, pero ang maximum dito is 9.5. So, kaya sa 9.5 magpo-fall yung mga values. Okay? Which is, tinabulate ko na rin dito. Okay, so, effective area. Okay. Okay. But 12 square meter lang ito. 24 ito. Okay. Yan. So anyway, kahit 12 yan or 24. So, lagpas pa rin naman siya ng 9.5. Ayun. Ito, Parley's effective area 2.08. Then, ito yung mga values niya. No? Then, nilagay ko rin yung Parley's spacing dito, no? 0.8. Dito, truss spacing is 2.5. Para pag minultiply ko itong mga values na to, pressure kasi ito eh. Sa spacing, so magiging line load siya. Ito nang magiging input sa STAAD mo. So, in kilonewton per meter. Okay? So, ganun din dito sa truss. Okay? So, naka-multiply ng 2.5. So, ito na yung mga direct load sa STAAD. Okay? So, pero kailangan pa natin i-calculate yung A, ano? Yung A value. Ngayon, okay? So, logical naman itong pressure na itong pressure diagram na to eh. So, 1, 2, 3. High pressure talaga dun sa mga corners. Okay? Doon talaga nagko-concentrate yung wind pressure. Okay? So, ayun, yung A, okay? Although i-calculate natin yung A, okay, for the purpose of the tutorial, pero isi-simplify din natin mamaya yan sa STAAD modeling. Ito yung structure natin, then ito yung calculation ng A. Okay, calculation ng A, so 10% of least horizontal dimension or 4H, whichever is smaller daw. Pero dapat hindi siya maging less than doon sa 4% of least horizontal dimension or 0.9. Okay, so yung 10% least horizontal dimension, so 8, then times mo yun sa 10%, so 0.8 meters. Kung 40% naman ang height, 0.48 sa 2.8. Pero dapat hindi siya whichever is smaller daw, no? Which is 0.9. Pero dapat hindi naman siya mas maliit doon sa maximum between these two. So, ang mag-govern dyan is 0.9. Okay? So, 0.9 yung magiging value ng A. Okay? Then, ganito yung magiging pressure diagram. Ano? Ayun, positive pressure. Okay? So, going down. Then, yung negative pressure naman, suction. So, ayan. So, ganyan magiging loading yan doon sa truss natin. Okay, so pwede na tayo mag-design ng purlins natin, no? Okay. Ito yung formula, Pnet, lambda, KZT, Pnet 9. So, yun. Pnet, lambda is 1, KZT is 1. So, since 1 naman to, kung ano yung 1, 1 lang itong values dito. So, kung ano yung mga pressure dito, yun na rin yung magiging input natin. Okay? Sa STAAD. Okay, so design na natin yung purlins natin. Okay, so open natin yung STAAD, and before So, before we create yung model, nag-create na ako ng uh, dalawang folders dito. Okay. Okay. Okay, which is for the concrete frame and for the roofing. So, roofing, dito yung natin i-design yung purlins, tsaka yung truss. Okay. And dito sa project natin, two-story residential building, tatlong software yung gagamitin natin, okay, sa design. Of course, yung STAAD, then yung STAAD Advanced Concrete RCDC, okay, and of course, kailangan natin yung AutoCAD. So, dito natin ipa-finalize yung mga drawings natin. Okay? So, anyway, mag-start na tayo uh, sa purlins design. So, ito yung STAAD ko. Okay, then click ako ng new project. Okay, then mas maganda siguro sa next video na lang ito, no? Okay, sa next video na lang siguro ito. Okay.